Hello, today we'll be covering angles and parallel lines. By the end of this video, you'll be able to use theorems to determine the relationships between specific pairs of angles and use algebra to find angle measurements. So we did this warm-up in class. You can take a second to do it on your own. Our corresponding angles postulate, I would say, is the second postulate theorem idea that we have learned so far this year. We have if two parallel lines are cut by a transversal, then each pair of corresponding angles is congruent. Notice we must have two parallel lines cut by a transversal for anything to follow to be true. So we have our parallel lines cut by a transversal. That means the corresponding angles are congruent. So angle 1 and 3 are congruent. 8 and 6 are congruent. 2 and 4 are congruent. 7 and 5 are congruent. Okay? Now I did say this is the second postulate or theorem idea we've learned. The first one was vertical angles theorem. You can shorten this to VAT or VAT. This basically says that vertical angles are congruent. Okay? Another thing that you will use on your homework is the idea of supplements. You can also think of this as supplementary. Means angles add to equal 180. Okay? Now this isn't a postulate or theorem, it just is supplements. Alright, so we're going to use these things. In the figure, the measure of angle 11 is 51. We're going to find the measure of each angle, so angle 15, and the measure of angle 16, and say which postulate or theorem we used. So angle 11 to angle 15, if you recall from 3.1, and if you don't recall, I have to go back and watch that video. These are corresponding angles. So math people are not very creative in coming up with names, so this is simply called the corresponding angles postulate. Okay, and if we look up here, corresponding angles postulate means our corresponding angles are congruent. So the measure of angle 15 is simply 51. From here we can find the measure of angle 6. So 16. Since we've already found the measure of angle 15, we can find the measure of angle 16 because these guys are vertical. So we can use the vertical angles theorem or VAT to say that the measure of angle 16 is 51 as well. Now I do want to point out that when you are writing these out, you must write the whole thing. If you simply write corresponding, you're only stating that angle 11 and angle 15 are corresponding. You're not stating anything about their congruences. So you must write corresponding angles postulate to say, for us to know, for anybody to know that they are congruent based on that. This next one's very similar. Notice, we must know that we have parallel lines, so if that's not there for us, we can't actually solve anything. So it says here in the figure A and B are parallel, and the measure of angle 18 is 42. We're going to find the measure of each angle, and then state our postulate or theorem. So we need to find 22 and 25. It is very similar to the last one. 18 to 22 is once again corresponding angles theorem. So that is equal to 42. And 22 to 25 are vertical. So this is vertical angles theorem. I'm going to go ahead and shorten it to VAT. That one is okay to shorten because everybody in the math world knows VAT is vertical angles theorem. So 25, measure of angle 25 is also 42 degrees. All right, so we had 3 things. We're going to add 3 more that we can use. So, alternate interior angles theorem. We have, once again, if 2 parallel lines are cut by a transversal, then each pair of alternate interior angles are congruent. So 1 and 3 are congruent because they're alternate interiors. 2 and 4 are congruent because they're alternate interiors. We're going to skip 3.2 for a second. We have alternate exterior angles theorem. If 2 parallel lines are cut by a transversal, then each pair of alternate exterior angles are congruent. So 6 and 8 are congruent. 5 and 7 are congruent. Now I skipped consecutive interior angles theorem because it's the only one, including supplement, that is different. Okay? So this one is if 2 parallel lines are cut by a transversal, then each pair of consecutive interior angles is supplementary. So 1 plus 2 is supplementary. They equal to 180. And angle 4 plus angle 3 adds to 180. So supplements and consecutive interior angles add to 180. The rest of them are congruent. So let's try some. Oh, let's try a proof first. So this is our first proof. Because we skipped chapter 2, I'm not going to expect you to do this proof on your own. We'll just walk through it together. Notice I always label my statements and reasons so I know which statement goes with which reason. We always start with our given. P is parallel to Q in this case. And also I'm going to include that T is the transversal. Usually we just use what's right by the given, but I'm going to include that as well. And our reason for this is always given. So you should never miss the first statement and reason. They're there for you. Now we need to figure out that we are going to prove angle 1 is congruent to angle 8. Now, it'd be really nice if we can say because of the alternate exterior angles theorem, we know they are, but we are trying to prove that. So we have to use our vertical angles theorem and our corresponding angles postulate to prove this. And then once we have these things proven, these 6 things, we can use them for the rest of the school year. Now we are only going to do one fleshed out proof. This one, we'll just take the other ones as is, but we could do proofs for them as well. So, as I said, we're going to use corresponding angles postulate and vertical angles theorem. So we'll get started. I'm going to say that angle 4 and angle 8 are congruent. And this is by corresponding angles postulate. Notice I wrote out the whole thing. I like to think in geometry that most of the time in math we walk around on a very linear path and we learn what we need to do and then we can take the next step. Sometimes in proofs though, we kind of have to take some jumps and not necessarily steps. So that first part was a pretty big jump. This next part is also kind of a big jump. I'm going to say 4 is also congruent to angle 1. This is by our vertical angles theorem, or VAT. Now that I have this, I said both angle 1 is congruent, angle 1 is congruent to angle 4, and angle 4 is congruent to 8. So, by the transitive property, we can say angle 1 is congruent to angle 8. And we can say angle congruence is transitive. okay? And when we finish a proof, we always either finish it with a box stating, I'm done, I have stated here. You should also never miss this one. The left side of the statement column should always be what you were supposed to prove, your very last one. I've finished that. I either put a box or I put QED, which I believe means it is finished. You can choose either one. Okay, now we're going to use some more things. The diagram represents the floor tiles in Michelle's house. The measure of angle 2 is 125. We need to find the measure of angle 3 and the measure of angle 4. So I like to trace out the angles we have. The one that they crossed is our transversal, and then the other two are our parallels. They aren't marked, but we're going to assume they're parallel because we couldn't do anything otherwise. I have alternate interior angles here. That means they are congruent. So this means the measure of angle 3 is 125. Okay, so we can't find the measure of angle 2, or we can't find the measure of angle 4 from angle 2. They don't have any angle pair specialness. But I do notice that angle 3 and angle 4 make up a straight line. So I can say 125, the measure of angle 3, plus the measure of angle 4, must equal 180. Solve. So the measure of angle 4 equals 55. Now we're going to do some algebra based on these. Once again, it doesn't say what we used. Maybe I'll put this up here. I used supplements here. And I used alternate interior angles theorem here. To figure out what those angles are. Now this one, it doesn't say to do that, we just have to solve for our variables. So I'm given 5 and 7, and I need to solve for x. Well, I know that these guys share this transversal and these two parallel lines, so they are considered corresponding angles. So by the corresponding angles postulate, they are congruent, which means I can set them equal. I solve, so x will equal 25. On part B, we're going to treat it as a new problem. We have 4 and 8. This one's a little more tricky because those are not any sort of angle pair, but I do know 8 and 6 are corresponding, which means the measure of angle 6 is congruent to the measure of angle 8. So the measure of angle 6 is also 4y. So now I have a straight line, so I can say that the measure of angle 4, 4y minus 25, plus 4y is the measure of angle 6, must equal 180. I distribute 4y minus 100 plus 4y equals 180. 8y minus 100 equals 180. Add 100. Divide by 8. So y will equal 35. All right. We have one more like this. This time, though, we have two variables, x's and y's. I need to solve using my same variable, which means I'll solve for x first. So I have angle 1 and angle 2. These guys are alternate exteriors. That means they are congruent, so I will set them equal. I'll distribute. I will solve. Oops, I messed that up. I forgot to distribute. So 12 will equal x. Solve for y then. I know that 1 and 3 are not any sort of angle pair. They don't share a transversal. But 2 and 3 are. They are corresponding. Corresponding angles are congruent. So I can set the measure of angle 2 equal to the measure of angle 3. So the measure of angle 3 is 5y plus 14. The measure of angle 2, we need to plug x back in so we can actually solve for y. Okay, so I simplified my left side. I can solve for y. So y will equal 20. Now, not always are our diagrams to scale, so you can plug these into the equations to check, but if it's not exactly right on the diagram, don't worry too much about it. They're not always to scale. So our last one, perpendicular transversal theorem. In a plane, if a line is perpendicular to one or two parallel lines, then it is perpendicular to the other. So if line A is parallel to line B, and line A is perpendicular to line T, that means line B is also perpendicular to line T. That's all that's saying. And that's it. Have a great afternoon.